Hello, today we are going to be talking about mountain building or orogeny. What are the kinds of mountains that exist? How do they form? How can we label and identify them? So, this is where the mountains of the world are. And hopefully, knowing what you know now about tectonic plates, you notice that most mountain ranges form along tectonic boundaries. You can see along the coast of North and South America, all the way here, where there are convergent, divergent, and transform boundaries. We get mountains forming. Where Africa is moving into Europe and has in the past, we can see there are mountains there. Along the other side of the Ring of Fire, there are mountains forming. And of course, the big one that is still happening, the Himalayan mountains, some of the biggest in the world, where the Indian plate is slamming into the Eurasian plate. So mountains typically form where there are these huge tectonic forces, where there are tectonic plates and movement deep within the earth, creating huge, huge forces that bend and shape the surface of the earth in magnificent ways. So, a mountain, by definition, is a peak that is elevated by at least 1,000 feet. For reference, the tallest buildings in downtown Dallas are around 900 feet, but most buildings in downtown Dallas are around 700 feet. So, none of those would be considered a mountain by any definition. So, these are things that are taller than the ground around them by a significant amount. Not a little hill, not a bump in the road, but 1,000 feet. And they form in an event called an orogeny or the orogenesis. Oro means mountain, genesis means beginning or start. So an orogenesis is the beginning of a mountain. And this is a large scale, typically pretty long event that creates a mountain. So when we are learning about the major events that happened in different periods in Earth history, you maybe saw something about an orogeny or an orogenesis. That was a time when mountains were forming. There are mountains still currently actively forming. The Himalayan orogeny is still ongoing as the Himalayan mountains continue to grow. And they form through a process called deformation, which is rocks being changed, their shape and size and position being changed through stress, which is a scientific term here, meaning the amount of force applied to an area. So there are three main ways that mountains can be deformed. There is folding, which is from a compressional force, things being squeezed together. Warping, which is from an upward force, things being pushed up. And faulting, which can happen from three different forces. Tension, things being pulled apart from each other. Compression, things being pushed together, or shearing, which is things sliding past each other. And all of this is possible because the crust is less dense than the other layers. The crust is the least dense of all the layers, and so it kind of floats on top of the mantle. Remember, the asthenosphere, which is the top of the mantle, can kind of flow like a liquid, and so the crust can float on top of that. And when mountains build up and become heavier, they can make the crust sink a little bit, and the asthenosphere, the mantle, can flow away. And if the mountains were to erode or glaciers were to melt, then it becomes lighter up here, and the mantle can flow back in. This is an idea called isostasy, which is that because the crust is floating, the mantle can move and come back, and mountains can shape the surface of the earth in more ways than you might be thinking. So there are four main types of mountains that we'll look at over time. We'll focus on the first three of these today. Folded mountains that are like pushing your sleeve up or pushing a carpet along a wall. There are folds that can create mountains. Fault block mountains, which form where there is a fault. A dome mountain, which forms when magma pushes the ground up but doesn't break the surface. and a volcanic mountain, which we won't talk about today. We'll save that for the next unit. But those form where there are volcanoes. This is a picture of the Grand Teton Range in Wyoming. That is a fault block range. We'll look at what the different forces involved are that can create mountains. Particularly, we'll focus on the difference between compressional stress, squeezing things together, and tension stress, pulling things apart. Compression can make folded and fault mountains, and tension, as weird as it is to think that the ground being pulled apart can make mountains, tension can create fault mountains. So we'll look in depth at how these different forces can create the different kinds of mountains. So first up is folded mountains. These, like I said, is like pushing your sleeve up on your arm, pushing a carpet along the floor against the wall. You get this buckling, this crumpling. You can see things are folded on top of each other. You get ripples that are like folds. The Swiss Alps, the Appalachian Mountains, the Himalayan Mountains, the Rocky Mountains, all of these are folded mountains. So maybe you've realized by the ones that I said there, but folded mountains are typically some of the largest mountains and often very complicated. There are three main types of folds that you should be familiar with. The anticline is when it folds up and it looks like an A or the top of an A. The fold points up. Syncline is the opposite. The fold points down. It looks like the bottom of the S. Oftentimes, anticlines and synclines form together. So you can see here there's an anticline, and then next to it is a syncline. These are typically, but not always, found in sets. Monoclines are a little bit less common, but they look like a stair. They look like a step down. Folds can be weird and complicated. There are, like I said, huge forces. So these can be symmetrical or not. They can fold over themselves. They can erode and fold some more. They can be all over the place. Anticlines and synclines are typically in sets, but folded mountains get to be huge and complicated. So they aren't always perfectly beautiful, clear what's happening where. The second type of mountain to be familiar with is a fault block mountain. Like I said, there can be compression and tension that create mountains. Faults form at more than just transform boundaries. A fault, a crack in the ground where the ground is shifting relative, can happen at all three boundary types. So hopefully you've kind of connected compression, things being squeezed together, goes really well with convergent, where there are plates moving together. Tension, where things are being pulled apart, goes really well with divergent, where plates are being pulled away from each other or are moving apart. So even though it's weird to think that there could be mountains at divergent boundaries or mountains forming where rocks are being pulled apart, and we'll see the different kinds of faults, something is still going to end up pushed up. And lots of times with these tension forces, you'll get an area called a basin and range. The basin is the low-lying part, and the range is a set of mountains. These often aren't as tall. These are shorter mountains, but you'll get a basin and range back and forth like that. In fact, there's a whole region of the U.S. in the Southwest called the Basin and Range. That is this on a large scale. Compression forces make folded mountains for sure. This is compression that is pushing my shirt sleeve up or could make a folded mountain. Compression can also lead to faults. And so you can get complex mountain ranges that are both folded and faulted because this compression has caused the rock to fold, but also caused faults to form. So you get some really complex mountains where there is compression because of the both folding and faulting. The Sierra Nevadas are another example of a fault block mountain. So when we have a fault, if we can label the blocks or the different pieces of ground that have moved or shifted, then we can figure out what kind of movement happened. And knowing what kind of movement happened can tell us what kind of force it was. So if I can tell how these two chunks of ground moved relative to each other, I can figure out whether it was compression or tension that created this fault. So we call each section a block, and I want to try to label the blocks. And I'm going to do that by imagining I am standing here. I'm imagining that this red dot is actually a little stick figure, and I am inside the fault. There's one wall that I am standing on and one block that is hanging above my head. The one that I am standing on is called the foot wall, and the one that is hanging above my head is called the hanging wall. So I'm going to always try to figure out how did the foot wall and the hanging wall move relative to each other. People knew about faults and the different types of faults before they fully understood plate tectonics. So this is something that people were doing before we knew and accepted that there were these massive plates moving around. But plate tectonics made these faults make a lot more sense. So the first type of fault, if I imagine I am standing here in the middle, I can see the wall that I am standing on, the foot wall, is actually up top. And the hanging wall, the one that is above my head, has moved down. So this is a normal fault, and the hanging wall has slid down or has been pulled down. This is because of tensional forces or divergence, things being pulled apart. The ground was being ripped apart, and this hanging wall slid down as it moved. Lots of times you'll see a series of normal faults where you can see here I could be standing there and the hanging wall went down, again here, again here. So when you have a series, it is called a Graben and Horst. These come from German words, so they are not quite what we would be used to saying, but the low-lying region is the Graben, and the uplifted region is the Horst. So a region of Graben and Horst form where there are multiple normal faults, like in the Basin Range in the US. And you get this series of faults and series of low-lying areas and uplifted areas. And if the normal faults are big enough, then the Horsts can become mountains. The second kind of fault is a reverse fault. So imagine now I'm standing here. The foot wall is the one underneath me. The hanging wall is the one above me. And in a reverse fault, it is the reverse of a normal. So the hanging wall goes up instead of down. This is because of compression, convergence, things being pushed together. The fault forms and something gives and slides up. There's also something called a thrust fault. This is the same as a reverse fault. A thrust fault is another version of a reverse fault. It just happens at a very low angle. So instead of a very harsh, sudden reverse fault, this is just a very almost flat. Again, because of compression, because of convergence, and lots of times subduction zones where one plate is moving under the other plate is considered a massive overthrust fault. That area where there is a fault, the rocks are broken and moving against each other, can be considered an overthrust fault, where one plate is moving under the other. The fourth kind of fault is a strike-slip fault. And here there isn't one section moving up or down. These are moving side to side. This is a shear force, like at a transform boundary, like San Andreas. So if I was in the middle of this fault, I'm not standing on anything and there's nothing above my head. So instead, these are moving side to side. And these typically won't form mountains unless there's a lot of other stuff happening as well. The Third kind of mountain is a dome mountain. These are sometimes called upwarped mountains because here we've got magma that is pushing up against the surface, but it does not break through. It's not a volcano where there is magma spewing out from the sides. It's just like a bubble that forms, so it doesn't break through. Lots of times these are isolated, not part of a chain or a range of mountains. The Adirondack Mountains are an example of a dome. The Black Hills in South Dakota, which is where Mount Rushmore is, are another example of these dome mountains, which is from upwarping, not compression, not tension, but magma pushing the ground up and not breaking through. The fourth and final kind of volcano or of mountains is volcanoes, and that is going to be what we start the next unit with. So we'll talk more about volcanoes in a couple classes. And that is it for the types of mountains and how they form. Bye bye.